So when we start considering the genomic options for the genetic evaluation of commercial animals, it's important to firstly go back and reflect on how the basis of genetic evaluation and the prediction of breeding value works. So for some time in the Australian beef industry, we've been able to predict the breeding value of seed stock animals. And that prediction of breeding value has been possible based on a couple of key fundamentals. First of all, we need to understand the relationship between animals, and then we use the information that's available on an animal and the animals to which it's related to predict its breeding value or to estimate its genetic merit. Now in the past, all that we had available to enable us to estimate or understand the relationship between animals was the pedigree information which was recorded. So on seed stock animals, the sire, the dam, any information about their progeny, etc., enabled the genetic evaluation software to go through and estimate the breeding value. Now one of the things which has evolved over the last couple of decades really, but certainly in the last 10 years in a very increasing speed and very quick way, is that we can now use genomics or DNA technology to better understand or estimate the relationship between two particular animals. And that suddenly means that we can start to predict the breeding value for animals on commercial animals. So where we have animals that don't have any pedigree information, so we don't necessarily know who their sire and the dam are, we can take a DNA sample and start to look at their relationship to other animals and use any information that's available to predict their breeding value. Of course, the DNA in itself only allows us to understand what the relationship is between two animals. The actual prediction of breeding value relies on the existence of some information. So by that I mean the existence of what we'll call a genomic reference population. Just to explain that a little bit further, if we look at a genomic profile for an animal, so we take a hair sample or we take a tissue sample out of its ear, we send that off to the DNA lab, then what the genotyping process does is it returns a DNA profile on those animals. And if we look at all the DNA profile in itself, it's not very informative. It's just a series of, depending how it's expressed, either a C, G, A or T, a series of letters, or often converted into a series of A's and B's. And the animals, depending on the different DNA platform, we get the series of these letters, around 50,000 of those. So it looks at 50,000 places in a lot of our technology that's available today across the animal's DNA. Now that in itself is not informative at all at describing the animal's breeding value. But what is informative is it enables us to go through and look at the genetic relationship that animal has to these animals in the genomic reference population. And the genomic reference population is really a group of animals that have been comprehensively performance recorded from conception right through to slaughter and have DNA information on them. And by understanding the relationship between the animal and those animals in the genomic reference population, then we can start to use the information on those animals to predict the breeding value of that commercial animal. Now the value of that prediction, so how accurately that can be, the breeding value can be predicted, is dependent on a number of key factors, and factors such as the size of the reference population. Generally, the more animals in that reference population, the more performance records, the more reliably that breeding value can be predicted. It's also impacted by things around how closely the animal is to the animals that exist within that reference population. So the more closely related an animal is, the better the prediction is of its total breeding value. Likewise, the value of the phenotypes or the performance information that's been collected on animals in that reference population in describing genetic differences. So for traits which are what we call lower heritability, so lesser the differences in the performance is due to genetic differences, so traits like fertility, then we need a lot more information in a lot more animals in that reference population to predict breeding value than say a high heritability trait, such as our weight and our carcass traits. It's also how relevant the performance information is that has been collected on those animals in the reference population in the production systems in which we're trying to select animals for. So if we have, ideally, we have performance measurements in the production system with which we're trying to select cattle. So all of those different things come into it. One of the things in the Angus breed which we are very fortunate to have, and it's due to the foresight of particularly the board of directors of Angus Australia and the management of Angus Australia 10 to 15 years ago, is that we have the Angus sire benchmarking program. So the Angus sire benchmarking program, initially set up as a young sire program that goes through and effectively uses fixed time AI breeding technology to tests 40 young sires, 40 to 50 young sires in commercial operations across Australia each year. It's now in its 11th year, so just joining its 11th cohort of animals. And what that has done by having a really comprehensively well-recorded population of animals, particularly for hard-to-measure traits, all with DNA information, it has developed and is delivering a really relevant, high-value genomic reference population for Angus breeders in Australia, and really enabling us now to start to make available genomic tools for the prediction of breeding value of commercial animals in the Angus breed. And if we delve into that a little bit more and start to look at, well, what is that Angus genomic reference population and how large it is I should say, a combination of information which has been collected on animals in the Angus sire benchmarking program, but also the information which has been collected by breeders in the seed stock industry over time. And the relative information depends on the different traits. So within our genomic reference population now, we have around, and it's growing all the time, but around 70 to 80,000 animals with DNA information. And then they've been recorded for a range of different information. So for easy to measure traits, like the weight traits, that reference population now is up in the kind of 40,000 and above. For some of the carcass traits and the harder to measure traits, then it's a lot lower. But for those hard to measure traits, pretty much based on the information which has been collected entirely in the Angus sire benchmarking program, we're now getting a reference population up to around 3,500 to 4,000 animals. And that's of a size because of the really high quality nature of that performance information and the relevance of those animals to the commercial animals that we're trying to test to really deliver some accuracy into the genomic predictions which we can make on commercial animals. So the take-home message out of that when we start to look at it is that genetic evaluation for commercial animals is now a reality. And Angus Australia, in collaboration with our DNA companies, our genotyping partners in Zoetis and Neogen, are really focused on the provision of genetic evaluation services for not only Australian seed stock animals, but now also for commercial Angus animals in the beef industry. And ultimately why we're focused on that from an Angus Australia perspective is so that we're better describing the genetics of both seed stock and commercial animals so we can make more accurate selection decisions and ultimately continue to improve the profitability of Angus genetics right through the beef supply chain. And there's consequently a range of options now available for commercial producers to get prediction of breeding value of those animals. So we have some genomics only services such as Angus Heifer Select, which is currently available, Angus Steer Select, which is under development, and also the recording of animals on the Angus Performance Register for those that want a little bit more information.